In this video, I'm going to explain how to create a chat app from scratch in C++. I'm going to be heavily using networking and concurrency in this video, so if you're inexperienced, I highly recommend that you watch my two videos on these two topics. For this video, I'm going to be using the Windows networking library, but it should be conceptually similar across platforms. This will be used for initializing the networking library. This will be used for configuring the local machine's IP address. This will be used as like the listening phone for our server, which will be accepting incoming connections and so forth. And this will be the buffer size so that we have a set number of bytes that we can receive per message sent. With this call, we're making it clear that we're requesting WinSock version 2.2. And in case this call does not return 0, we're throwing an exception because it signifies that we were not able to initialize the WinSock library. With this code, we're preparing the IP and port information that our server will bind to. With this hint structure, we're making it clear that we want to use IPv4, which is 32-bit IP addresses. We want to use the TCP protocol, which is a connection-oriented protocol, and we want to create a server. This call to getAttr_info generates a socket address that we can bind to on our local machine using port 8080, and it will have all the characteristics described here. This code right here creates our actual server socket, and it will return invalid socket if this socket cannot be created. This call to bind associates our server socket with our server's IP address and port number. This call to listen puts our server socket in listening mode, which allows it to accept incoming connections. Our server will heavily utilize concurrency. We'll have one thread which will be accepting incoming connections and appending them here. We'll have another thread which will be listening in on this condition variable and then propagating the messages to the other clients. We'll have one thread which will be closing connections by listening in on this condition variable and then removing empty clients from here, as well as closing the socket. For each client that is connected to our server, there will be a thread that is running this function to receive data from that client. Our receiving threads will continue to receive data until they are requested to stop. This call to receive will block until the client socket sends some data or is closed. If the client socket sends data, it will return the number of bytes received, and it will write into this buffer at most buffer size characters. If the client socket is closed or there's an error that occurs, however, the number of bytes received will be less than or equal to 0, in which case this loop stops. Because we are using the TCP protocol, a message may be sent in chunks. To work around this issue, we will have a buffer which we will append to every time we receive data, and a new line character will represent each message that is sent. As long as we can find a new line character in the buffer, there is a message that has not been propagated yet. So we'll extract that unsent message from the buffer, and then we'll put it into a message which will contain the IP address of the sender, the actual contents of the message itself, as well as the timestamp associated with when we're sending out this message. And then we'll get a lock on the mutex to print the message to the console, as well as send it to the, or append it to the unsent messages queue notify the condition variable to notify the thread that will be propagating these unsent messages. Once we're done receiving data, we'll lock the mutex to print a message that our client has disconnected. We will append the iterator to the clients in our list so that it can be removed from the list, as well as have the client socket be disconnected. And we will also notify the closed connection thread. Until a stop is requested, this thread will continue the poll for incoming connections every quarter of a second. To begin, we create a file descriptor set. We clear it. We append our server socket to it. We'll wait for a quarter of a second during our call to select. And then after the 0.25 seconds, this will return greater than 0 if our server socket is ready to accept incoming connections. If all goes well, our call to accept will return the new incoming client socket, and it will write that client's address information here. And with our call to get name info, we can extract the new client's IP address. With this call to get name info, we are requesting our operating system to read the data that is given to us here from our call to accept and write to this buffer the IP address. This thread will continue to propagate unsent messages to other client sockets until a stop is requested. This line will block until the send message condition variable is notified and a stop is requested, or the queue of unsent messages is not empty. If a stop is requested, this thread will terminate execution immediately. Otherwise, it will continue to pop unsent messages off of the queue and send them to the clients. Once an unsent message is popped off the queue, we'll iterate through each of the clients, and so long as the client is not the sender, we will send the unsent message to that client. Since we are using TCP, we know that a message can be split up into chunks, so we'll keep track of how many bytes have currently been sent, and we're not going to stop until all of the bytes in the message have been sent. So with each call to send, it will return the number of bytes sent. So in this case, we're sending to the client socket that we're currently working with. We're going to send starting at index at the index, and we're going to send at most buffer size elements. And of course, if send receives a number less than or equal to 0, an error or a disconnection occurred. So we're just going to stop and begin propagating the message to other clients. Until requested to stop, this thread can continue to be notified to close connections. This line will continue to block until the close connection condition variable is notified and either a stop is requested or the number of unclosed connections is greater than 0. As long as the number of unclosed connections is greater than 0, we will close the socket and we will erase that client from the clients list. The person running the server will themselves be able to send messages to the other clients. The user input will be used to create a string which will signify that the message is coming from the server, as well as contain information about the time the message is being sent. And then a lock will be acquired, and this message will be pushed onto the unsent messages queue, and the propagate message thread will be notified to propagate the message. In order for this line of code to be reached, the user running the server must have hit enter without entering in any data. And so we're going to free the resources and then print a message saying that our server has gone offline. To deallocate our resources, we are first going to invoke request stop on our stop source to try and put an end to all the threads that are running. We're going to shut down our server socket so that calls that would otherwise block, such as a call to receive, will stop blocking and allow these threads to stop running. And then we're going to ensure that all of these threads right here have stopped running before we invoke close socket on our server socket. Then we're going to free our server address and invoke WSA cleanup, which will deallocate all the stuff that's been allocated by setting up the WinSock library. Our chat client will be remarkably close to our chat server, so all of this should be quite familiar to you, but nevertheless, we'll briefly go over this so you understand how this works. To connect to our server, we are going to first initialize the WinSock library. Here, we're of course requesting version 2.2. For our address lookup, we're going to be using IPv4, just like in the server, and IPv4 is of course 32-bit IP addresses. We're going to be using the TCP protocol, which means it's connection based and messages might not be sent all at once. Instead of putting null pointer here for the call to get adder info, we're going to have the user input the server's IP address, and we're going to of course use port 8080. And if get adder info here does not return 0, then we're unable to configure the requested IP address. We then create a client socket with this information from our server's IP address, and if this call to socket returns an invalid socket, then we were unable to create the socket. And then after we've created the socket, we call connect and pass in the address and the length of the address into connect. And of course, if that does not receive or return 0, then we are unable to connect to the server. Because we are creating a chat client, we do not have an AI passive flag put in here. And we're not calling listen or bind, we're just calling connect. In case an exception is thrown while we're trying to connect to the server, we'll output that error and then call cleanup, and we'll analyze cleanup at the very end. We'll create a receive thread, which will be there will only be one thread running on the client side, the thread that's receiving data from the server. The server will be propagating other clients' messages back to us. And so until a stop is requested on the receive thread, we're going to have this buffer, which will be being filled with data by calling the receive method. And it will write at most buffer size elements to this buffer. And then if bytes receives is less than or equal to 0, that means either a disconnection occurred with the server or there was an error in receiving data. And so this thread will stop receiving data. Otherwise, though, we'll null terminate this buffer and append it to this buffer, which will be, because since we're using TCP, messages can be broken up into chunks. And so we know that we know we have a full message if there's like a null or a new line character at the very end. So as long as there's a new line character in the receive data buffer, we know we have a message. So we extract that message, create a lock, or yeah, lock our mutex, and output that message, and then we erase it from the receive data buffer. Much like the server, the client will be able to input data and send messages. If the user merely hits enter, that signifies they want to disconnect from the client, and then this loop will end. Otherwise, however, that message will be sent to the server. Because we're using TCP and our messages can be split up into chunks, we use the new line character to signify the end of a message. And so we'll append a new line to our input, and we'll have a loop so that every single byte in our message is sent, including the new line character, to the server. And if send ever receives or ever returns a value less than or equal to 0, that means, of course, an error or a disconnection happened, in which case we'll signify that the sending failed. And if the sending failed, then this loop that's taking in user input will end, and then we'll have the cleanup. To clean up our resources, we first invoke request stop on a receive thread. Then we invoke shutdown on our client socket so that calls to receive will stop blocking. And then before we close the socket, we verify that the receive thread has stopped running. So we invoke join. If it's still joinable, we close the client socket, and then we free the memory for the server address and invoke WSA cleanup. Now that I'm finished programming, I'm actually going to demonstrate my chat app now. So I have the server program running on one computer and the client program running on two other computers. And I'm going to enter in the IP address of the machine which is running the server. And we can see that I've connected and it's registered. And I can send messages from one client and it'll propagate through the server to the other clients. Send messages from any one of these computers, and it'll show up on the other two. With each message or each action that occurs is timestamped. I can disconnect from one client and it will register on the server. Thank you for watching this video. All of the code I wrote in this video can be found in my GitHub.